Good to go. Hi everyone. Thanks a million for coming along tonight. Just before we get started, I'd just like to thank Anton for speaking for us tonight. And I'd like to thank Intercom as well for hosting us, and I'd like to thank Nearform for sponsoring as well. We have the ladies' toilets are just through the doors here. Men's are just further down across from the bar. We have food and drinks. Please help yourselves. And the pizza's arriving around 10 to 8, roughly. So it should be there hopefully on time. So I'd just like to introduce Anton anyways, and thanks a million for coming along.
Right, cheers. Do I need this?
Or do you want to stand?
Yeah, would you mind? Because I am going to be typing a little bit. Cheers. Well, he's getting the stand then. Cheers, Sean. Thanks Nearform for inviting us along. I'm Anthony Worley at Digit9 on Twitter, and this evening I will be talking about observability in production. Some badges about the things that I do in Dublin and on the general community. So I'm part of Node School Dublin. I also which is at the end, usually at the end of the month on Thursdays, we get together, sort of teach people who are new to Node, go through some tutorials. But the mentor group that we have in there's some folks from that here tonight, and we do just have a general jam on whatever we're thinking about in Node.js as well. So if you're doing projects or anything like that and just want to have a chat about what you're doing, or even got something to show that you want to have in a sort of sidebar conversation, definitely do that at Node School. Started a FreeBSD thing this year, talking about FreeBSD operating system. I'll be showing some of the features of that tonight. FreeBSD is an interesting operating system. Netflix are using it to deploy their CDN on, and the WhatsApp infrastructure is also running on that. Netflix are doing some interesting work there on the network performance. So if you're doing IO-bound operations and you're seriously into that type of stuff, then definitely take a look at FreeBSD. Node, I really look after some of the libraries and build problems that you have on the not normal operating systems. So Linux and Mac are well covered by the community, but I find myself getting involved in resolving Node issues, resolving Windows issues, resolving FreeBSD stuff, and I'm also involved with Illumos, which was Solaris. So that's really what I do for the Node Foundation. And finally, I also support a library, or I contribute to a dtrace library, libusdt. So if some of the technology we see tonight for dynamic tracing of the Node.js application runtime, the same library is used for Python, used for Perl, used for Ruby. The underlying subsystem there is libusdt, and I do throw contributions into that as well. Okay, so that's about me. So what are we going to talk about tonight? So I'm going to give some background on production observability. I'm going to describe distributed tracing in general forms. What is it? What it's about? It's not that complicated, but just to give you sort of a picture of what's going on. Going to look at Zipkin, which is Twitter's implementation of distributed tracing. I'm going to give a very lightweight demo of that, like a real simple, this hello world of distributed tracing, using Loopback, which is an open source framework that IBM, the company I work for, that we sponsor. I'll then talk a little bit about flame graphs. I know we've had Matteo in from Nearform. He spoke about it, was it 4 months ago? And he maybe even smaller. Right, okay. Around about that time. He also did a workshop down at NodeConf.eu, which is scheduled for November this year. Definitely worthwhile getting along to that. Highly recommend it. But I'm going to go into that again because being able to do this in production and understand what flame graphs are is so important for actually solving production issues. So you really can't go over it enough. And then I'm just going to go an end-to-end demo then, sort of a distributed system. It's a fake distributed system, but like all the properties of, or the important properties of a distributed system, and then resolving that with some dtrace. So you should see how this whole flow comes together and how it could help you in production. And I have a mic stand. Hello, London. Cool. Right, yeah, so now that is sort of over here, is it? Right, I'll work from here. So yeah, well, like, what are we talking about when we're talking about production? Why are we talking about distributed systems in production? So this is from left to right. This is sort of like a history, if you want, of application architecture. You could kind of argue from sort of mid-90s through to present day. It's not absolutely a timeline, so we still see the stuff on the left being produced today for certain reasons, and there were certainly people doing the microservice application piece way back. Definitely weren't calling it that then, but it's definitely a trending from left to right, okay? So historically, we would have seen monolithic applications where you have all your business logic contained within a single process. And that single process would usually just have talked directly to a single database or a database cluster in sort of high availability scenarios. And in those types of scenarios, a lot of your performance was dependent on the actual database. So a lot of debugging tools you would have used would have been built into the database. Certainly, and I have written those monolithic applications, certainly spent a lot of time in SQL, tracing tools, on Microsoft SQL Server. There's some great tracing tools in there, but that's where you were looking for most of your performance gains. Usually you were disk and bad database configurations there. But that was just the nature of the applications at the time. They weren't internet scale applications, they were usually enterprise style applications. Then as they grew out, you sort of got this, you got separate processes running application servers, but they were still talking to a single database, and the complexity of them, although there may have been some calls between them, there may have been one or two, so they weren't that hard to sort of reason about. And this, like I was really doing that up to about 10 years ago, sort of hopping between monolithic apps and internally componentized apps, okay? So, and then since then, we've seen a sort of move to microservices. Definitely people who were talking about service-oriented architectures 10 years ago, they were trying to implement microservices. I think they struggled a little bit with the database side, but they were definitely talking about contained application runtime with their own contained data sources as well. And the complexity that brings when you have multiple services talking to each other with their own data sources, it grows, okay? So is everybody sort of clear about what's happened on the complexity of applications? Yes, would you agree? Yeah, things have got more complex. Okay, so thanks. So and this is what I'm seeing today. So although like I deal with it, I look after Node applications and talk to customers about their Node instances all over Europe, and this is not an uncommon scenario for what they're trying to achieve or what they have achieved. So we see they're exposing APIs to do business with, and I'm heavily involved in sort of API implementations. And underneath those APIs, we're seeing lots of services. We're calling them microservices. And I will say microservices one more time. We're seeing microservices to call another microservices, sometimes popping out to call business partners, sometimes from the same microservice calling a SaaS application. We're seeing like, all this sort of complexity in deployments in production. Okay, so we've agreed complexity is growing, and because this complexity is growing, and because the ownership of all those different components, maybe your SaaS provider, maybe a business partner, maybe another team within your own organization, one of the biggest problems is that the only place where everything runs at the same time, at the same configuration, is in production. So while you may have development environments, you may have test, pre-prod, prod, and those are all sort of valid things to have, what actually happens is you can't guarantee what's going to be deployed into production, because keeping those environments into sync with production is actually not a realistic expectation. And that's not to say we shouldn't do it, because it teases out a lot of things, but our expectation on what those environments are providing us by definition, is lowering. And I know some folks in the audience that have had direct experience with keeping prod, pre-prod, and all those environments sort of in sync. So what we're seeing, a lot of people are actually holding their hands up now and saying is actually, do you know what? There are certain things you're only going to see in production. Let's get the tools. Let's get the understanding about how we debug when something goes wrong in production and we can't replicate it in any other environment. What happens then? Right? So, and like I say, the specific reasons for that is versioning. The actual parameter settings that are there are only specific to production, and typically the load that you get as well is only available to you in production. That doesn't mean to say you can't hammer a service in test, but the interactions between services are they're really hard to replicate outside of a production environment. Okay, so to help solve that problem then, enter distributed tracing, okay? So the definition that I'm running with is it's a collection of end-to-end latency graphs, okay? And by graphs, I mean jagged objects or just objects that represent the latency of a system end-to-end. And these distributed tracing then allows you to compare these traces and reason about these traces. So it's that simple. I really don't want to blind you with rocket science here. There's no ooh moment with it, but it's just to have a definition out there. So underneath that then, what you have is these traces are basically composed of spans, and a span is an operation. So if you think of a span being a single request, usually time-stamped events, i.e. start, finish, but you can decorate events within that if you wanted. And you can also associate tags with that specific request. So this request went to this endpoint, and the CPU at the time had this, was at this, and you can associate that with a span, and then you group spans into a trace. Okay? So this is actually ripped off Adrian Cole's presentation. But I think it illustrates the point absolutely fine. Starting to get into a bit of graphics here. You have this operation, and as I said, you have an event when the server received the message, which is the request start, and then when the server's finished sending, the request send, and those are two events. And it's decorated, as I mentioned, HTTP request ID, size, URL, the IP, all those types of things. Okay. So that's what a span looks like. So those concepts are being used by the Cloud Foundation, Native Cloud Foundation, which is a body of organizations that are coming together to put standards together around different aspects of the cloud stack. So they're using that model to talk about an implementation of distributed tracing called OpenTrace. Zipkin predates that, so it isn't quite following the standard yet, but they are putting together an implementation of the standard under the OpenZipkin project, and they're very sort of sympathetic to that. I think they run an implementation in Go right now. The OpenZipkin that you'll find at this URL is currently a Java implementation, but that's all fine. And that's what we're going to look at now in terms of a demonstration. And just as an interesting aside, while I was putting this slide together today, did anybody see the news of Twitter running their mobile site on Node? They announced that a couple of weeks ago. So all of Twitter's mobile web application is served from a Node.js stack, predominantly Express.js. So it's again, we're going to be looking at Express later on, but great that they chose Express because it's part of the JavaScript Foundation. It's not some esoteric thing that some company's looking after. So yeah, delighted about that. So, simple demo of OpenZipkin then. Here we go. So I'm not brave enough to do this on Windows. And I've lost my mirror. Huh. Apologies for a second. My laptop's decided to extend the view, so I can't see what's going on, so I can't type. Graphics options, personalize. Nope. Windows W. Nope. There we go. Duplicate. Apply. Keep the changes. Marvelous. Yeah, apologies there. It's a PowerPoint sort of automatically did the extend thing, so I had a slide presentation view here, and then anyway, we're good. We're back in action. So right. Okay. So. So, who uses frameworks to build their API? Does anybody build APIs in here? Okay, ish. It doesn't matter if you just mess around. You built APIs. So you've done that in Express. Yeah. Happy.js. Mainly Express, it seems to be. Okay. So what I'm going to demonstrate then is basically using our loopback framework. So last month we had a loopback application. We announced a command line tool for building APIs that was originally called Strong Loop, but that was like a full stack API deployment. So it was process management in there, clustering, all sorts of good stuff. So we've actually taken all that out, and we've now just got an API development command line tool that isn't cluttered in with the difference between development and deployment. This is just around sort of the development thing. It's made a lot of sense. It certainly makes a lot of sense to me. So hopefully we'll see this in action now. So basically you npm actually. Shall we? How's that? Is that better? Are we good? Right, yeah. So you npm install loopback -cli, and that installs this command called loopback, which is available as it's shortened to LB, okay? And it's basically a wrapper around a set of Yeoman tech. And I name an application here, so I'm just going to call this node dub 2017. Okay, grand. Goes off, and it gives me an option. So loopback as a technology has been out there. It's used in GoDaddy. It's been out there for 3 years now. So it's had a lot of hammering in production. So it's up to our long-term support from the community is 2.x, but we're now up to moving to 3.x. So I strongly encourage you to sort of have a look at that. And you've given the project a name here, so you have an option. You have options of it can build you an API server with local user authentication auth, an auth implementation burnt into that. You can build an empty server, which is very close to an Express app, just an Express folder structure. We've got a vanilla hello world, which it just shows a remote method invocation, or which is just basically mapping a function to a URL. And then we also have a model-driven technology in Loopback, where you can specify JSON files to describe models, and then that model will automatically provide CRUD operations to some back-end persistence mechanism. So either in memory or all of your favorite SQL and NoSQL servers. I can't think of one off the top of my head we don't cover. So yeah, if that interests you, sort of, if you have a database structure and you just want to put together an API really fast for it, definitely take a look at this. So I'm going to choose just a simple controller with a hello method, okay? And as you can see, basically, it's the important one here is the server.server.js. That's your Express application. And then the rest is around providing the configuration / models for the service to run. Okay? And now we're going to pray to the NPM gods together. Would this be faster in yarn, Dario, yeah? Do you think? Yeah. Okay, so that's been generated out. So that's just interfering with play there. Right. So we call it node.2017. So if we have a look at okay, so what this has done is it's just generated me some stub code on a model called message, and it's created what we call a remote method in our terminology called greet, and provide a simple implementation of that. So if I give it a message, it will print back that message saying hello, or whatever I provide it, and if I don't provide it anything, it will just say hello. So there's no special magic in there. It's just a Node, like I said, a Node.js Express application. And actually, before I go in there, what I want to do is remember what I'm actually talking about and put some distributed tracing in this. And I think my machine's now going to reboot. The joy. Yeah. Don't do this to me now. Yeah, we might have got away with it. Apologies there, my Windows is giving me some grief. So, yeah, right, so that's what the application stack looks like. Has anybody any questions about building APIs with loopback there? Does that all sort of make sense? Yeah, you've got a command line, generates an Express application, and generates some stub code for a method. Okay, so what I want to do is I put together a library earlier this week, and that sort of ties in with that. So it's LB for loopback zipkin, and I want to go -I, don't I? So the way loopback works is if you have, if you're familiar with sort of Express middleware, if you have a module that exposes sort of request, response, next, error type interface, returns that from a module, you can just use it straight away in the loopback infrastructure. So what do I mean by that is I can go, so in here, what I'm doing is I have a set of sort of standard middleware that you use in Express applications like Helmet. What else have we got in here? Session, authentication. It's got routes, so it uses loopbacks to apply the routes that we've defined to the application. And you can also serve static files out of here, or configure it to serve static files. We'll have a look at that later. So now I've installed that zipkin module, I can just say lb zipkin, not sending any parameters, now I can know that. Okay, So that gives me you can see the middleware message there. So my beautiful piece of debugging, Zipkin middleware for the win in capital letters. And it's set up a web server and also an API Explorer here that you get sort of out of the box. So let's take a look at that. Oops, sorry, I've stopped the process. Let's have a look at that. On the internet. Yeah, so this is the Explorer interface that you get. That's the greet. And is everybody familiar with this Swagger auto generation stuff? Yeah, we all sort of know this. Yeah, grand. So you get this out of the box, and I can test it here. So if I say no Dublin, then you can try it, and I can see that's come back. Okay. So what that also means is that because I've just done that configuration change, I should now be able to search for, as you can probably see, I've been doing some testing on this. What I want to do, yeah. So, time is it now? Anybody? 22. 8. All right, cheers, yeah. Cheers, so, let's go for 20. Right, so yeah, you can see that less than a minute ago, because I've put some tracing within that framework, within that application, all requests to that application are now logged into Zipkin. So because I'm just making straight requests to the API, all my calls are just single span calls, so I'm not calling any services from there or anything like that, but I can get that sort of level of detail that I mentioned in the server receive and the server send. Okay, and I can see the URL and 200. Okay, so that's how you configure distributed tracing for Express applications, despite Windows wanting to reboot. Okay. Right. So that was a simple demo of Zipkin. So a little bit then. So actually, before I go into the phone graphs, does anybody have any questions on that? About any of that we just saw? APIs, the tracing or anything? No. Okay. So flame graphs. What they are is snapshots of the current stack on the CPU grouped together, okay? So don't really think of the bottom as time, just think of them as the amount of times that particular call has been seen on the CPU, right? So I always find it better, sort of, I think I'm meant to be playing guitar now. So I always find it handier to think about it or to understand it is if you actually look at the data that goes into the flame graph. Okay, so as you can see here, the command isn't as important at the top, but that's basically the command to run a dtrace on your system. But what you get back is the stack trace, which is the stack trace there. If you've ever been in Chrome debugging tools, exactly the same as when you hover, when you look at the stack trace there, that's the JavaScript stack trace. This is the full stack trace of the whole node runtime, so both the C and the JavaScript level. And then the important thing is the number at the bottom, which is at 4884, which when it's plotted back in here, that number will be proportional to however many other system calls have been on that side. So if 4,884 was a lot of your sample set, then there will be a lot of it here. Okay? And we'll look at another example of that, but that's roughly what's going on there. Okay? So again, you'll put the slides out there, but there's an ACM article from June this year. Last year, 2016. Basically, Brendan Gregg, performance engineer at Netflix, goes into a hell of a lot of detail about how you read performance flame graphs and what they're useful for, the different types of scenario. So what we're using them for, what I'm showing here, is actually understanding where in your application you're spending most of your time. But you can also use it for analyzing a lot of different things about a system. So it's very worthwhile sort of reading Brendan's paper there. From personal experience, this technology saved me for some very substantial customers twice last year. And I know twice doesn't sound like a lot, but when there's a lot of money on the line, being able to take a phone call from a developer in the middle of a country in Europe and say, okay, give me access to the system, and be able to tell them exactly tell them where in their stack something is going slow, because I get calls like, my node is slow. And it's like, oh, right, so what are you doing? Well, I'm actually calling these 30,000 things. So being able to sort of go from zero to understanding what part of a service isn't performing properly within a day is something that, having spent a lot of time debugging different types of systems, I'd just say it's invaluable. So if you can deploy, so what we're looking at here is FreeBSD. If you can't use dtrace directly on FreeBSD, Matteo in Nearform, he's put out OX, which is basically uses the Linux perf utilities to give you the same sort of, exactly the same outputs. Very, very much recommend diving into that if you have to deploy on Linux. Personally, I'd say go on FreeBSD, but hey. And there's a link there to sort of dive in. So that's just one iteration around this. So I'm actually going to do another demo again, and it'll be the same things that we've seen, but just sort of what does that look like end to end then, okay? So what we have in here is, I'll start that off, I have a service called Iffy, and Iffy is Iffy. It's in here. So yeah, we have just simple index.js, and it's a simple Express application. And I've actually run this in 2 scenarios. So currently, what it does is it does some calculation for an amount of time. It does a for loop for a certain amount of time, and then it sends a response. Okay. So what I've done is I've generated 2 flame graphs based on what that looks like. But I'm going to run this so we can see what the traces look like, and then I'll show the flame graph so you can understand how I got from the flame graph to the service. Okay. So yeah, let's spin Iffy up. So Iffy actually at the moment isn't that Iffy. He's just bad all the time, because we don't have the random in. We're just setting the random to a high number. So let's spin him up. So I already have him up. He's already been Iffy. Yeah, there we go. Right then. So what I also have is for right. So this is a more complete example. So I have a client, which is basically a. So we just have a look at him actually. So this is from the OpenZipkin on the side, you have Zipkin.js, which is a JS set of client libraries that you can go and sort of integrate with whatever you're doing. So I basically cut and paste that out of there, and I'm going to make a call to a service that I've set up called messages greet, and which in turn is going to call Iffy. So we'll see that full sort of stack trace from the client to a middleware, to a middle service, to a back-end service. And then all this client does is just write out whatever response I get there. Okay, that's what the client's doing. In terms of the additional configuration of the server, what I've done is what you have to do to enable the client to send the right headers and make sure the clients come backwards and forwards, so that the headers come backwards and forwards properly, you have to add another piece of middleware. So package, so we got it there. Further up. Put it in there. No, I haven't got it in there. So if So this is a really simple piece of middleware, but you can just see what I meant by how you can plug these things in. So this is what a middleware package looks like for Strong Loop when you want to use it within the configuration utilities. So this is loopback Zipkin client, and really it's just sending back these response headers. So the client forwards and backwards knows what's going on. Okay. So that's the only additional piece of magic in there from a Zipkin perspective. From a loopback perspective, then I've just configured that as I did the other loopback Zipkin service. So let's just have a look at that. Yeah, so we can just see it there, like I did before. For the first example, I just put in loopback Zipkin. For this example, I've added loopback Zipkin client, so it'll all sort of tie it together and make sure we know what's going on there. Okay, so I should now just be able to start this up. So let's go node.js. Okay. Cut that out. And if the demo gods are with us. Yeah, okay. So that client then has sent a request to the backend. The backend said, I've taken, so to calculate whatever it was, whatever order of magnitude the for loop was, it takes 628 milliseconds to go end to end on that. So if we then look at that in here, we go back to find a trace. I've set up this, I've called the trace from the browser, and you can see that less than a minute ago, it's actually crossed this 3 spans here. So I've gone from client to server to backend. And I can see the different names of those down here. I can see a summary of the time that they took. So my backend I can see already took 643 against the default service, which took 700. So I can see the chunk of the time has been taken by that backend. Okay, and the interesting thing about this is that I don't need to know what service or the layout of the services that I'm actually calling. I get that for free. I can see the architecture. So it's the system's starting to document itself. So that's a really sort of surprising it's not sort of on the marketing literature of Zipkin, but it is a really, really good property in terms of how you write systems that are self-documented systems. It's not just about generating Swagger files and and client stubs that go with those Swagger files. It's how do you understand how the system's used as well. So, and having struggled with understanding these in several jobs that I've had, I think this is sort of really handy as well, you know. So I can click on that then, and as you can see here, the default service has taken, as we said, it's taken 700 milliseconds all told, and I can see that my get has taken the majority of the time. So if I was responsible for the backend service, I could go away and fix that. Or if it was owned by another team, I've got something very concrete to say, we've got crap response times, we've got poor response times, and you're in the mix for most of this. So I'm going to pass this over to you if that's the type of organization that you're working in, which is also handy as well. It's a lot of transparency, because as you know, if you're doing front-end development as well, you always get the first call. Your application is slow, and that's not necessarily always the case. Right. So once I've identified that, then what I did, or what you can do is run dtrace scripts, which was in the sample that I showed you, and you can generate flame graphs against that. So what I'll do here is, in order to get something that looks sensible, you have to sort of run it for, say, a minute or so. So I'll save us from that, because I've got a feeling I'm actually running over here. This is going on a bit longer than I thought it would. So we'll just dive in here. So yeah, let's have a look at the normal one first. Right, okay. So when we run dtrace against that, against the IFI service, as it's currently configured with the, can't remember how many hundreds, thousands, millions that call is, milliseconds that it's waiting, the iterations is going through the for loop. You can see that the stack is blocking, is blocking, or it's spending time, it's spending most of the computation time at the waiter. So that's taking that's the full stack. When we execute a lot of requests against that service, that's what's, we can see very, very, very clearly that, apologies there, that the top call that's holding all of that stack is waiter. Is that clear? Can everybody see where that's coming from? Where I'm getting that from? So that very top stack is waiter, and that was the name of the function in the code that was taking all the time. And I've done that without adding any, if we look back into that code, there's no instrumentation code in there. There's no specific logging in waiter to go and say, oh, waiter, if waiter, then go and do this, which is what we normally have to do when we're debugging or when we're looking at performance issues, is put process times all over the place and count that, and then all of a sudden the logging of that's taking more time than the actual thing, and it's like, what's going on? Yeah, you don't get that problem with dtrace. So you get straight to analyzing the problem that's within your service. So just for sort of more reality, or just so we understand what it could look like on the when it's more random. So that's what the random one looks like. So most of the time it's kind of behaving. So it's just doing normal things, but we see the spike here, or we see the specific block here, and we see waiter at the top of it. And this is, like, even this is quite simple for dtrace. So, for flame graphs, you will get spikes, a lot of these spikes in a production system, but it's very easy to browse across the top of them and understand exactly what's the biggest one that you can read is usually a good sort of key indicator of what's going on there. Okay, and so yeah, that's how you go and sort of instrument a system from client through to server, through to backend. I should have also mentioned that the IFI service itself isn't instrumented. It's just a service that's downstream. The only bits that are instrumented, should I say, are the client and the Zipkin server, and the middleware server, and the specific call within that middleware server. So actually, before I finish, we will just take a quick sort another look at that. Any questions on that? Dtrace, flame graphs, how we, no? Is that all making sense? Yeah, ish.
I do have one.
Cool, yeah.
Is that better than New Relic?
Is that better than New Relic?
Yeah.
So, it depends on the type of things that you're doing. I find what I enjoy about this is that it's at the system level. So New Relic is an application at the application level, and it's got a lot more management features about it. It's certainly a lot nicer UI. You're not just typing directly into the command prompt, and you can get a lot without having to invest that much time into understanding New Relic. So they add a lot of value there. Got to be careful. They're a partner of ours. So, but yeah, it fits into a certain space. But what I'm talking about here is when so that works well when you've got a separate team that are looking after servers and watching those things, and when things go yellow or things go red, they have to go and do something. But where I am is in more of a sort of an agile type scenario here, where it turns out that the developer is actually responsible when it lands into production. And we are seeing that more and more. But they're solving different problems, I think, would be my take on it. But they've got some great tech in there. What was I doing there? I said I wanted a question, and I didn't really, did I?
No, that's fine.
Oh, that was it, showing the middleware. Yeah, so what you need to do in Zipkin. So we'll have a look at that meet again. CVI, comma, models, message.js, right. Yeah. So what I've done, what you have to do in here, and this is sort of interesting in so much as the problem of distributed tracing is it has to be solved currently in the application stack. And what I mean by that is you have to implement code in your application or at your application level, be it at the infrastructure, in your infrastructure code for your application, or actually in the business logic code itself, to make these requests. And that's more of a problem with the fact that the TCP standards, God knows, that there's no way you're going to get custom headers in there. And when other standards were coming out, people weren't really thinking about how you do distributed tracing at that time. So what I'd hope to see, and it won't be tomorrow, but is to see this type of thing come into the HTTP 3 standards, I guess, I don't know. But come into that level, so you get this for free at the stack, and you don't have to put it in your application code. Because having to transport this with your app code it does feel a little janky. But I think it's well worth being able to understand your system, because in the end you're going to be doing some sort of logging anyway. So why not just do distributed logging or distributed tracing as part of that? All right. So we'll just minus down a little bit here, shall we? Just a little bit. Is that that's probably still okay-ish? Yeah. Some squinting going on there. 2 rows back. Yeah. So I'm using REST. So there's a few libraries, sort of standard client Node.js client libraries. So fetch, REST. There's probably others that you can basically wrap with Zipkin. So when you use that client library, you wrap it. You create a Zipkin object, wrap the client in Zipkin, and you get that magic for free. So what that means is that if you want end-to-end tracing, but you go to a team in your organization, they're going, I'm not putting Zipkin in this, you can still get that end-to-end view of what's going on. So you can still go to them with that dashboard and say, that's slow, and you're slow, look, and have that conversation without having to have that end-to-end scenario as well. Okay, so just to sum up then, I suppose, I'm in here. Yep. So demo end. So yeah, I mentioned there effective triage, which is a nice way of saying, yeah, you can actually see who's doing what and why, and get issues resolved faster within your organization, within your architecture, and your architecture discovery as well, which is an interesting piece. So to wrap up then, You can build services quickly with loopback CLI. I think I put together an API there in literally seconds and instrumented it with Zipkin. You can see how services misbehave with Zipkin, and you can isolate performance issues using flame graphs. And like I say, well, all this technology that we've used here has been focused on Node. If you're in heterogeneous environments, like there's Zipkin for Java, there's Zipkin for Ruby, like there's all the good stuff, so it plays well across heterogeneous stacks. So it's seriously well worth the investigation. And with that, the pizza's arrived, and we're good. Okay, I think that's all I have. Yes, that's all I have. Thanks very much, folks. I hope you found it interesting.
Does anyone have any questions?
One quick question.
Yes.
Just because the Relic question came up, have you guys, does Zipkin try and monkey patch existing node libraries, or is it very hands-off and kind of making use of the middlewares to kind of write that, as you said, infrastructure code yourself?
So for the client implementation, monkey patch is a very specific phrase. So does it override known functions on an object?
I know that's how the Relic does their side of things.
Okay.
They go into the known functions inside, like things like SQL, MongoDB on the lower level, and they essentially swap out the lower level implementation and then put in their own thing that wraps it.
Right.
Some problems sometimes, but
Okay.
so does it can do the same thing, or is it very much you have to do it?
So I would say for the client implementations that we saw there, so for the wrap around the REST, so the client library for making the request from the middle to the back end, that looks very much to me like it's a monkey patch. So yeah, because for each HTTP client implementation, there's a Zipkin implementation. So there's a Zipkin Kubeflow or something like that. There's a Zipkin fetch. There's a Zipkin REST, which you wrap around that specific object. So yes, I'd say for that is what's going on there. In terms of the HTTP server, yeah, I'd say for Express, it's doing it again because it's Zipkin Express. So it wouldn't surprise me if there is magic like that going on. Yeah. So trade-offs there. I mean, I can instrument an Express library in front of you in 2 minutes. You pay your money.
I'm in favor of that sort of stuff, by the way. It's not like I'm...
Okay. Oh yeah. It's plus and minuses, but yeah, it's an interesting point. Yeah. Is that all we have? Well, seriously, thanks very much for coming out again to talk about distributed tracing and observability in production. I didn't think there'd be this many people interested in it in Dublin, but cheers, thanks again. Nice one.